Let's talk about systems. Systems consist of two chief things. They consist of objects, and an object can be anything you can think of, any object at all, a rock, a block, inclines, even the earth itself, and interactions. Interactions are the forces that the objects in your system exert on each other. And so, in total, a system is a collection of objects and their interactions. Any object or force from an object that is not inside your system is considered to be outside your system or external to your system or part of what we call the environment. Objects outside your system can exert forces on other objects outside the system, but objects outside the system can also exert forces on objects inside your system. Forces on objects inside your system that come from objects outside your system are called external forces. An external force, then, is a force exerted by an object outside the system on an object inside the system. On the other hand, we have internal forces, and those are the forces that the objects inside your system exert on each other. Just like with coordinate systems, you may define your system to include or exclude whatever objects you please. You will get the same answer no matter what. However, also just like with coordinate systems, once you have defined a system, you must stick with that system for the remainder of the problem. And so we have it. We have our system, and we have the environment, and we have external forces and internal forces. Let's now see an example of how this works. Consider the following simple scenario. We have a rock falling under the influence of gravity to the ground. There are two systems we could define here. Let's consider the system of the rock alone. In this system, the only object in our system is the rock. We can draw a box around it, and then anything outside that blue box is outside the system. This means in this system, the Earth is outside the system. The Earth exerts a gravitational force on the rock, and therefore the gravitational force of the Earth on the rock is also outside the system. It is an external force. We can also consider another system. In this system, we expand our system to include the Earth. In this system, the Earth is now inside the system, and the gravitational force that the Earth exerts on the mass is now inside the system, and also the gravitational force that the mass exerts on the Earth is inside our system. The Earth, the mass, and their gravitational forces on each other are inside our system. Those gravitational forces are now internal forces. Another object, maybe some block sitting over here, it is outside our system. The gravitational force that this mass exerts on the rock is an external force, and likewise the gravitational force that the mass exerts on the Earth is an external force. Note, this is because the Earth is inside our system, and this block over here is not. So our block exerts a gravitational force on the Earth that is an external force. Note that objects inside the system can exert forces on objects outside the system. This rock is exerting a gravitational force on the block that is outside our system. Because the block is outside our system, this gravitational force here is not considered to be inside the system, but do note that objects in the system can exert forces on objects external to the system. Usually, though, we're just interested on the forces exerted on objects inside our system, because if we were interested in objects outside our system, we would probably include it in the system too. Let's now consider a more complicated scenario of a block sliding down an incline while being attached to a spring that is also pulling it down the incline. The incline also has friction. The incline, if we want, we can consider it to have mass also. Let's consider the different systems we can think of for this scenario. We have the system of just the block. In this system, all the forces acting on the block are external to the system. We have the gravitational force from the Earth, we have the spring, we have the normal force, we have kinetic friction, and if we consider the mass of the incline, we also have the gravitational force from the incline. All of these forces are acting on the object. All of these forces are external to the system. Let us now consider the system of the block and the incline together. In this system, the forces between the block and incline, now that the incline is inside the system, are now internal forces. And so, the normal force coming from the incline on the block and the friction force coming from the block rubbing against the incline, as well as the gravitational force of the incline on the block, if you include the incline's mass, all of these are now internal forces. The spring force and the gravitational force from the Earth on the mass, and the gravitational force from the Earth on the incline, if you include the mass of the incline, are external forces. They are objects and forces outside the system. Let's now expand our system to include the spring. Now that the spring is inside the system, the force of the spring acting on the block is now an internal force, and likewise the reaction force of the block on the spring going the other direction is inside the system. Friction, normal force, gravitational forces, all of the forces are inside the system now, except for the force of the Earth on the block and potentially the incline also. And then finally, let's expand our system to include the Earth. And now in this system, all the objects and all the forces are inside the system. There are no external forces to consider because we have not drawn any other objects that are exerting forces on objects inside our system. The gravitational force from the Earth on our masses, and likewise the gravitational forces of the masses on the Earth, are now internal forces. So these are some examples of systems and how you can draw them to solve problems by making forces and objects become internal to your system or leaving them external to your system.